Hello, my name is Mo Ewing, and I'm going to give a little presentation today on introduction to um, moss sporophytes. And that sporophytes for me in this thing is the capsules and the setas. When I was putting this together, I didn't want to just do a description of the different characteristics, but I wanted to try to link it as closely as possible to one of the keys that we use in New Mexico and Colorado, and that's the Flora Neomexicana IV Bryophytes by Kelly, Russ, and Karen of our group. And I collect mosses mostly in the Southwest Colorado and New Mexico, but also in New England. And if you've used keys from the Northeast or the East, you'll find that the bryologists use a lot of characteristics of capsules in their mosses. I mean, in their couplets, in the keys. Um, and but you can't really do that in the Southwest because so many of our mosses don't come with um, sporophytes. And so they have to be identified vegetatively. So I thought what I would do is by concentrating on Flora Neomexicana keys, that it would just kind of tailor this to people who collect in the Southwest. I guess there were a lot of people from Arizona today that would fall into that. I don't think you put Californians in there because it's things are pretty wet there. But anyway, so so what I did was that I went through the keys for Flora Neomexicana and tried to pick out couplets that described characteristics of sporophytes, and then tried to illustrate them. And this was a challenge, and you'll see there are some characteristics of particular mosses that I wasn't able to actually get photos or illustrations on. But I have found kind of supplements for that. Okay, so when you're looking at sporophytes, you've got to be a little bit careful because unlike vegetative characteristics, sporophytes change depending on how mature they are. And here we are with Ceratodon purpureus. We were talking about that earlier. And that's a Ceratodon is a perfect example of um, how different capsules can look whether they're mature or not. In Ceratodon, when they start out, they're these long, skinny little things, and then they plump up and they develop a calyptra, which is on top here. And then the calyptra falls off and they get to a more mature state and they look like this. And this was really what we were looking at uh, in um, in that photo. I don't think there were any calyptras on there in the moss that we were looking at earlier. If people were here, and this is usually a mature capsule like this is usually what's described um, in the keys. And then when the perculum pops off and the spores come out and they dry up, they look more like this. So you have to be a little bit careful when you're looking at capsules and try to determine whether you think they are mature. And I think trying to remember in the Ceratodon that we were looking at earlier, I think it was mostly like this. Okay, so let's just take a look at where we are in the life cycle. Mosses start off with the spore. It hits the ground and grows into protonema, and then that develops into the gametophyte, which is what you normally will see when you're looking at mosses, particularly in the Southwest, if there are no capsules on them. And on that gametophyte, there's the male part, which is the antheridium, and the female part, which is the arctogonium, and the antheridium shoots the sperm out. The sperm swims across a thin film on the leaves. It goes and fertilizes the arctogonium, and then that develops into the sporophyte. And so it's the sporophytes that we're actually looking at here. And then the sporophyte starts with a calyptra on the top, which eventually, usually, sloughs off. It's deciduous. Sometimes they're deciduous and sometimes they're not. We'll see that. And that pops off, revealing the operculum, which pops off. And then you end up with a peristome, which are these kind of teeth that let the spores out, and then you're back to the beginning. But this is what we're looking at. We're looking at the sporophytes. So we have the gametophyte down here, and then the seta grows out of the end of the branch or from the side of the branch if it's a pluricarp, attaches to the capsule, which consists of the urn, which is the part at the top, and sometimes the neck, which is this part down in here, is used as in the couplets to distinguish species. And then you have the peristome, which is this guy here, which is these little teeth that open up and let the sperm out. Sperm, no, not the sperm, spores. And then the next segment up is called the annulus, and that's just a ring of cells that sit on the top here, and that those cells break down and release the operculum. And I didn't. I'm not sure. Somebody can correct me. By the way, if I say something that's absolutely wrong, raise your hand, scream, and correct me, because I did this thing partially because I'm not very good with sporophytes coming from the Southwest. And then over the top of the whole thing is the calyptra. So, and then the calyptra is the part that's very often deciduous and pops off. This is the calyptra here, the operculum. And then I didn't understand this illustration because they show this as the annulus, but I would guess that the annulus is a ring of a ring that runs around underneath the operculum.
It is.
Okay, so here we go. We'll start out with the capsules. We'll start out actually with the seta. And one of the things that's used, one of the ways of distinguishing species is the length of the seta. Now, let me just step back for a minute and indicate, what I've done here. What I did was that I looked into the keys and found particular couplets in various keys. And this couplet is couplet 35 in the Grimiaceae key to all species in Flora Neomexicana. And I indicate whether it's a single characteristic, which means that when you get to that couplet, the only characteristic is the sporophyte description, which means that you have to have sporophytes in order to get beyond that couplet. So in this case, this couplet 35 in the Grimiaceae key to all species distinguishes Grimmia pallifera, which is this guy here, from Grimmia longistratris. Now, Grimmia is a particularly, what's the word I should use for it? Painful. Grimmiaceae is particularly painful family. And so and Kelly and et al. In Flora Mexicana actually has three keys for Grimmia. One of them is the Grimmiaceae key to the genera, because there are several genera in Grimmiaceae. And in that key, a lot of characteristics are single characteristics of sporophytes. And then there's another Grimmiaceae key to all species, where all the species of each of the genera are all lumped into one, as if they were one genus or one family. And that's this key here, Grimmiaceae key to all species. And then Grimmia has its own key for just the Grimmia genus. So, so that's just to give you an idea where all these things come from. And in this couplet, the capsules are described as either being immersed or exerted. And in Grimmia pallifera, the capsules are immersed, which means that they sit down at the same level or below the leaves that surround their base, which are the perichital leaves. Those are the leaves that surround the base of the seta. And so in Grimmia pallifera, capsules are immersed, and Grimmia longistratris, the capsules are exerted. And how you tell that is that if you can see the seta, you can see that here and here. It means these capsules are sit just above the leaves. Then there are other couplets where the capsules are called emergent, and they would be capsules that stick way above the leaves with a long seta. And a lot of the uh, a lot of the uh, seta a lot of the seta couplets are simply a measurement. And they'll say in species A, the seta is 1 to 2 millimeters long, and in species B, the seta is like 4 to 6 millimeters long. So the seta is used to just in terms of its length. Another seta characteristic is in the Plagiominium genera, in couplet 3, Plagiominium solari is described as having a single seta, which you can see here, and Plagiominium medium has 1 to 5 setas coming out of the perichitum, which are these leaves here. And you can see there's a single seta here, and in this one there are 5 setas coming out. I've seen quite a lot of plagiominiums, but I've never seen them with capsule. I would love to see this but I've never seen that before. So it's the number of seta per perichitum is another characteristic. Another uh, seta description that is used is whether or not the seta is attached eccentrically to the capsule base, which is in this case here, or whether it's in wait a minute, I've got to cover that's covered up there, or it's attached to the centrally to the capsule base. And you can see if this was attached to the central, that seta would be attached about here, but it's attached kind of on the outside. And in here, Grimmia pulvinata, you can see it comes right down into the center of the bottom of the capsule. And that This is again a single characteristic at the beginning of the genus key in couplet one. All of the species that are attached eccentrically uh, are on one side of the couplet and attached centrally on the other. So there are four species that are attached eccentrically, and then all the other grimias are attached um, centrally. Okay, moving on to capsule shape. I thought it would be easier just to do show you illustrations of the different shapes. Um, and this I didn't actually link to any particular couplet. So capsules can be ovoid. Sometimes this is called cupulate because it's shaped like a cup. Sometimes capsules are flattened on one side, as you can see here. Sometimes they're globose or subglobose, round or almost round, cylindric or oblong, shaped like kind of an oval, or piriform, shaped like a pear. Some of them are curved, and we'll see those, I think, in the next slide, actually. Some of them are asymmetric. They're shorter on one side than the other. Some of them are angled, four angled or six angles. Polytrichum in the Polytrichaceae, you're angled. And then some are called sulcate, which are just grooved. They're not angled, they just have grooves. And some of them have a little goiter at the base of the capsule, and they're called strumos. Okay. So actually, you can see this guy I would call cupulate, and this one over here is certainly irregular. So in the Psychometrium, in the Funariaceae key in couplet 5, Psychometrium piriforme is separated from Funaria hygrometrica by saying in Psychometrium piriforme, the capsule is erect, and you can see that these are definitely erect from the seta. But in Funaria, the capsule is strongly inclined, as you can see, is a good example there and here, and usually very asymmetric. And I zoomed in on that to show you how asymmetric that can be. Another example of that, and I pick that because sometimes, we'll run into this actually in this presentation. Sometimes some of these characteristics are pretty hard to see. In this case, in the distichium key in couplet 1, again, this is the only characteristic that's used to separate distichium capillaceum from distichium inclinatum. And in distichium capillaceum, the capsules are erect. And yeah, you can see that that one isn't there. So I'll just forget about that one. But the majority of them are erect, except for that one, I guess. And in distichium inclinatum, you can see that the capsules are inclined. Just an interesting note, I've found in this process the species description, the species name of a lot of these things comes from what the capsules are doing, and the capsules here are inclining, and so it's distichium inclinatum. But I wanted to show this because if you look at a lot of these capsules are not inclined, and so you need to look at a bunch of them to see whether or not they're more of them are inclined than not. Okay. Now, this is a perfect example, and I kept it for this reason, a perfect example of a characteristic that isn't very apparent. And so in the Flora Neomexicana keys, in Polia key, couplet 7, there is a single characteristic that is used to distinguish these two species, and that's the neck of the length of the neck of the capsule. And these are, unless they were improperly um, identified on the internet, this is Polia cruda and this is Polia longicola. And in the Flora Neomexicana, in Polia cruda, it says the neck of the capsule is half or less of the length of the urn. And I left these on here because to me it's kind of difficult to tell where the neck begins and ends. But in this one, I think probably this is probably the neck. But if you go over here and look at Polia longicola, where the neck of the capsule is supposed to be half to equaling the length of the urn, it's really hard to see where that is. Where does the neck begin and end? And so some of these characteristics are kind of hard to see. Maybe in a different illustration, they would be easier to see. But this is one of the ones that's used to distinguish species, these two species. Another capsule characteristic is whether the capsules are ribbed or smooth. This is found in Orthotrichaceae in this family. The ribs are used in several different for several different species. But for Orthotrichum levigatum, the capsules are described as smooth, and for Orthotrichum animalum, the capsules are 16 ribbed. So I went online and I got this illustration of Orthotrichum levigatum, uh, and um, uh, and they pointed out that sometimes the species is weakly ribbed, but in this case, I think they're clearly different because the 16 ribbed Orthotrichum animalum is ribbed all the way from the top to the bottom, and clearly is to the top to the bottom. But in levigatum, if they're weakly ribbed, it looks like the ribs don't go all the way to the bottom. And you can see in this case, it's not ribbed at all. In Orthotrichum, there are also some species that are 8-ribbed. So ribs are uh, one of the characteristics which is used. So adhesins, really early in the key, in the Acrocarpus key in C, which is uh, uh, kind of near the beginning point of the keys, in couplet 7, Grimiaceae is uh, separated from Andrea by how the capsule deheses. And in actually in Grimiaceae, and actually in most species in Colorado and New Mexico, the capsule is dehesed by opening at the top. The operculum sits at the top and pops off, and then the spores are dispersed, but from the end. In Andrea, the capsule doesn't have an operculum, but opens and lets out the spores by splitting down the sides. And I don't know, I'm not sure, somebody can make a maybe speak to this, but I think Andrea is well, the only genus that I know that where the capsule opens up this way. It opens up into four longitudinal slits, and that is shape is described as being like a Chinese lantern, which is kind of cool. Okay. The operculum is used to distinguish some species. Um, in the Grimiachaeta all species, couplet 35, Grimia prolifera is separated from Grimia longistratris by whether or not the operculum is short-beaked, which you can see here. These beaks are really short, less than or half or less the length of the urn, or long-beaked in Grimia longistratris, where the beak is about 3/4 of the length of the urn. You can see that here. Again, notice the species name is Longistratris. That probably refers to the length of the beak, I'm guessing. Is also used as a way of separating characteristics. In the Gramiaceae key again, but this is the key to the genera couplet 4. The calyptra shape is used to distinguish these two species, Grimia pulvinata. Or actually, it's not really the shape; it's really the size. The size of the calyptra. In Grimia pulvinata, the calyptra is described as being small, half of the length of the capsule, and you can see that here. Here's a perfect, is a good example of the calyptra being half of the length of the capsule. And in Casinodon, Caliptratus, the calyptra is large, covering more than half of the capsule. So you can see that here. And this one's pretty easy to see. Also, that was calyptra size. Calyptra shape is also used to distinguish species. In the Pterogonurum key in couplet 1, and actually I think that these are the only two species in the Pterogonium key. The only the characteristic of calyptra shape is used, and in Pterogonium or Vedum, the calyptra is described as being cuculate, and often longer than the capsule. Cuculate means spoon-shaped, and you can see this is a good example here where it's as long as the capsule and it's shaped like a spoon. This is shaped like a spoon here. Yeah, here's a good one down here. But in Pterogonium subsessile, the calyptra is described as being mitrate. And this is one of these things where I was not able to get a photo of the calyptra of Pterogonium subsessile, which is described as being a small mitrate shorter than the capsule, which obviously isn't true here. This is just a photograph of a calyptra that is mitrate. And mitrate is described as being like a bishop's mitre, where you have slits up the side and little square things around here. But in Pterogonium subsessile, the calyptra is shorter than the capsule, so it would sit up in here, and then the bottom of the miter is splayed out on the sides. I would have loved to have gotten a photograph of that, but I couldn't. But you can see the difference between the miters and the subsocilia, the spoon-shaped guys. Peristome is used to separate species, the characteristic. In the pollia key, and pollia is one of these things where you very often need to have capsules to identify species. And in this couplet 4, you need to have the capsules. Elongata and obtusifolia are separated from Wallenbergii and nutans by the presence of cilia. And if you look on this side in Wallenbergii and nutans, the cilia are these like little hairs here, and these are the actual teeth. So you can see the little hairs are quite different. And the peristome cilia are present and long. They are almost as long as the teeth. But in elongata and obtusifolia, there are no cilia present. The other peristome characteristic that's used to separate species is whether or not the peristome is single or double. And I'd go back to when we were talking about the parts of the capsule. There was a good example of double, but this is also a good example. Pellucidum, Orthotrichum pellucidum, is separated from alpestri by whether or not the peristome is single or double. And in this Orthotrichum alpestri, you can see that the peristome, the teeth on the outside, which is called the exostome, are these thick shaped teeth. And on the inside is another row of teeth in the endosome that are these little hair-like things. I'm not quite sure, what the advantage of having these two different kinds of teeth are, but leave that up to Mother Nature. I couldn't get a really close view of Orthotrichum pellucidum to see whether or not there were teeth inside there. You're just going to have to take my word for it that there's a single circle of teeth there. And then the third example of peristome teeth that I found to separate the characteristics to separate species are whether or not how many teeth segments there are. And this appears in the tortula key in couplet 14, separates tortula planothobia from tortula brevipipes. In tortula planothoba, there are 16 teeth, peristome teeth in 16 segments, and in tortula brevipipes, peristome has 32 segments. I couldn't get a photograph of either of these, but I found tortula muralis, which, like tortula brevipipes, has 32 teeth segments. And if you take the time, you can count that there are 32. These are the spores around the outside, which is pretty cool. This is a pretty cool picture, I think. So that's another characteristic of peristome that's used to describe species. Then one other thing that I found, which a part of the capsule that I have not described yet, is called the columella. And a columella is a bunch of columella is an organ that runs up the middle of the capsule. This is the columella. And in the Grimiaceae key, genera key, couplet 3, Schistidium is separated from Grimia. Schistidium genus is separated from Grimia genus by whether or not the columella is attached to the operculum. And in this case, you can see here's the columella that runs down the middle of the capsule, and it's attached to the operculum. I could not get a photo of the operculum not being attached to the operculum. So I did this illustration to say that it, although I have never seen this myself, the columella probably is just attached to the bottom of the peristome and doesn't run all the way up to the operculum. But it certainly seems to here. So, and I think this is the final one. On the outside of the capsule are exothecial cells. That's just the cells of the capsule. And in the Grimiaceae key to species couplet 7, Schistidium atrofuscum is distinguished from Schistidium duprettii by whether or not there are stomata. And stomata are kind of like mouth-shaped pores, same kinds of things in vascular plants. And in mosses, the stomata open up to release moisture to help mature spores inside, and they look like this. I couldn't get photographs or illustrations of these particular species, so I just thought I'd show you a couple of different illustrations of what the stomata look like. And so that's it. I think I'm not sure that I got all of the really the most important characteristics, but I hope that that's helpful in getting you through at least Flora Neomexicana. And I just wanted to, at the end here, show a place that I go to in the summertime sometimes, the Abbey Rockefeller Garden in Seal Harbor, Maine, which has the most incredible amount of mosses. There are like acres of forest that are just absolutely covered with mosses like this. A really incredible place, something that you definitely, well, no, actually, there's some places in Colorado where you see the mosses cover the ground, but not like this. So thank you very much.